Hi there. I'm here with the Chapter 7 homework, okay? The other day I asked you to do problem number 4, all parts, and then on my most recent lecture I added 6, 7, 9, and 10, okay? So let's chip away at this. Let's take a look first. Okay, that's number 4. We have two companies that we're considering on a standalone basis, Watson and Masiello. Okay, when I say standalone, that means I'm not planning on buying both and combining them into a portfolio. I'm simply comparing one against the other with respect to their returns and their risks, okay? Our economist says there are 3 possible economic conditions. There could be more, okay, but we've chosen 3. And we have to assign 100% likelihood of their occurrence in total, and the economist says, well, I think it's 30, 40, 30. Very good. Okay, under those circumstances, based on past research, Watson has returned 100%, 15%, and a negative 70. So Watson can be all over the map. That's a profile of a very, very risky stock, as I think you already know. Okay, we're going to see some high numbers, folks. Don't be off-put by them. Masiello, on the other hand, in the same 3 conditions, earns 20%, 15%, and 10% historically. I begin by asking you what the expected rate of return is for each company. Okay, in the text, we laid problems out like this. We indicated, let me do Watson first of all. This is part A. Okay, Watson. What we're going to do is we'll put down the condition. Okay, I'll put down the probability of that condition occurring. I will put down the return of Watson under those conditions, and then I'm going to put down the product. Okay? So that's how we lay this out, friends. Let's give ourselves a little neatness here. I'll center all of those and I'll underline them for you. Okay, again, I remind you, this is Watson. So what is the condition? We're looking at a strong economy, a normal economy, or a weak economy. And we've assigned likelihoods of 30%, 40%, and 30%, okay? Let me just add to remind you that that is a percentage probability. Likelihood of occurrence. Watson again has a return of 100% during strong times, only 15% during normal times, and during weak times they might have 70%. All right? Now I'm going to do the product, which is going to be found by taking the return and multiplying by the probability, and I'm going to divide that by 100. Because again, those are percents. Okay? I'm going to replicate those down, just like that. And I'm going to give us a couple decimal places. All right, we didn't need them. And we see that if we take those numbers and combine them, which I will do here. Okay, let's use our borders. I'm going to add those 3 to come up with a weighted average. I get 15%. Okay? Very good. So I'm done with Watson. Now by comparison, I'll take these same numbers, copy, paste, and we'll look at our other company, whose name is Masiello. Okay, she was one of our former deans, if you wonder where I get the name from. And of course, Watson refers to Denise Watson, who is our assistant dean at SCS, okay? Same conditions apply. If the economy works with probability for one company, it's going to be the same for the other company. All of us work on the same stage. Okay. The return is different, however, with Masiello, as I indicated in the book. Those 3 numbers change, and I have made them, you'll notice, I've made them both the same ERR, okay? They both have the same expected rate of return. All right, and I'm just going to take a moment here, and I'm going to insert a line there, okay, and I'm going to insert a line here, just to emphasize that those 2 numbers are indeed the same. All right, very good. So that is part A. What is the expected rate of return for each company? I then go on to ask you, what is the standard deviation, the sigma for each company? So now we're moving into part B. Okay, to find the sigma, we lay it out just as the book did. And here are the headings that we use, going across just like I indicate early in the chapter. Okay. Oh, and I forgot to indicate who this is. This first go-around is for Watson. So we'll take them in that order, okay? Watson first, Masiello second. And what's next? After the ERR, we have the difference between the two preceding columns. Then I take the difference and I square it. I multiply it by itself, SQUARED. Next, I carry down my probability percentage, just like I did in my ERR, and I take the product. Okay, let's stop right there and stop filling in numbers. Okay, for Watson, my returns are 100, 15, and -70. Those numbers were all given. My ERR is 15 for all three. Okay? Okay, very good. Hang on. I think I want to carry this out to 2 decimal places, I think would suffice. Okay. So now let's start filling all this in. I'm going to take my column A number and subtract my column B number. I get a difference of 85. I multiply that down. Okay. I take my difference and I square it. I multiply it by itself. Those are my numbers. The probability, 0.3, 0.4, 0.3. Okay, that was all given. And then I take my difference squared multiplied by its probability, and I get 216750. I carry that number down to all 3 rows, and there is my data. Okay, now what I do, friends, is I sum those. I add those 3 together, just like this. And that number, as I told you in my video lecture, is called a variance. Okay? My standard deviation, also known as my sigma, is found by taking the square root of that variance. Okay? So I'm going to say SQRT parens, that number, and the square root of 4335 is 65.84. Okay? So as usual, I'm going to highlight all of my answers to each one of the parts of this problem in yellow. Okay? So what you've just done is you have solved Watson's calculation. What I'm going to do is I'm going to copy it and carry it down, and we'll solve for our other company, Masiello. Okay? Now, Masiello also has an ERR of 15. I made them the same number. Okay? So Masiello's return happens to be different. Their return is 20, 15, and 10 under the same 3 conditions. I left all the math formulas the same, so you don't have to recalculate anything. So my answers are, Watson's sigma is 65.84. That's a wicked big sigma, you'll agree. Okay? The one for Masiello is much smaller, but we already knew, again, smallest sigma means smaller risk. We already knew just by intuitively glancing at Watson's number that it would be the riskier of the 2 stocks. The sigma proves that to us. Okay? So part C, well, I just answered it, right? Masiello's, make sure I spell that right, smallest sigma implies, pardon my typing tonight, that it's the safer of the 2. Smaller is safer, bigger is better. Because these companies have the same ERR, we don't have to go any further. Okay? We know that Masiello is safer, Watson is riskier. Okay, so far so good. Let me save this for you. Part D says, okay, there's a 68.3% chance, that's our master math rule, that the return for each of these companies will be within what range? Okay, that's an excellent question. What I'm going to do is I'm going to put Watson out here, and I'm going to put Masiello. I've been speaking all day, friends, so pardon me, I have to be rude here for a second. My voice is fading fast, and I have to give a 3-hour lecture tomorrow, so I should be in great shape for that. Okay, so we're going to talk about Watson first. We know that their expected rate of return is 15%. And we're going to say minus one standard deviation. One standard deviation is 65.84. Okay? So if I take 15 minus 65.84, and I'm going to put 2 decimal places on these, 1, 2, okay? 50.84, and I'm going to say that's as low as I expect with a 68.3% possibility. Then I'm going to say, what about the high side? I'm going to say 15% plus 65.84. So my conclusion is there's a 68.3% probability that Watson could go as low as 50.84 return and as high as 80.84. What about Masiello? We'll do the same thing. They've got the same ERR. They've got a 3.87 sigma, and on the high side, I'm going to add the same sigma, 3.87. All right, so 15 minus 3.87 and 15 plus 3.87. The conclusion is a 68.3% chance that Masiello's return, even though you're expecting 15, could go as low as 11.13 and as high as 18.87. Look at the spread on Watson versus the spread on Masiello. Lower spread, lower risk. All right, similarly, part E of this question says, all right, there's a 95.5% chance, okay, that the return for each of them will be within what range? Okay, 95.5% means plus or minus 2 standard deviations. So do exactly the same thing that we did a moment ago. I'm just going to copy and paste them as a result, and then we'll fix them. So copy, and let's stick that puppy right here. Okay, so this time it's going to be 15%, just like before, minus 65.84, 2 standard deviations, minus another 65.84. Okay, and here it's going to be 15%, plus 65.84, plus another 65.84. Let's see where that puts us, okay? 15 minus 65.84 minus 65.84. Whoa, big range. You could lose a lot of money there, okay? This company could experience a huge loss. Okay, let's try it going the other way. You can see that Watson's all over the map, okay? Their return could be as high as $147, as low as a loss of $116, okay? Now we do the same thing with our other company. So we're going to take 15% minus 3.87 minus another 3.87. That's 2 standard deviations. And of course we do the same thing on the plus side. All right, let's math it out and see what we get. We've got 15 plus 3.8, I'm sorry, 15 minus 3.87 minus 3.87. Typing is getting a little slower here as the night goes on. On the high side, I've got plus 3.87 plus another 3.87. So it could go as high. That number does not look right for some reason. What's wrong here? Okay, let's try that one more time. 15 plus 3.87 plus 3.87. Okay, so Masiello has a 95% chance of its return going as low as 7 and as high as 22, even though we're expecting 15. Okay, those are the conclusions that standard deviation leads us to. All right, part F says, what is the coefficient of variation for each of the companies? Okay, the coefficient of variation is found by taking the standard deviation, or the sigma, and dividing by the expected rate of return. Okay? Now, we know that Watson is the riskier of these two stocks. If they had different ERRs, then we would have to do the coefficient of variation because sigma is not good enough if the ERRs are different. Okay, we saw that in the example in the chapter with Jackson and Conway. Here, because the ERRs are the same, we already know what our decision is. Masiello is safer. But I asked you to do the CV anyway, so let's do it. Okay, so let's hang Watson out here. and put Mazziello right alongside, and just fill in our factors. We know that the standard deviation for Watson is 65.84, and for Mazziello it is 3.7. Okay, and I'll give these 2 decimal places for us. All right, and I know that the ERR for both companies is 15, just like that. Okay, so in spite of its fancy polysyllabic name, the coefficient of variation, which we affectionately call the CV, is as simple as taking the sigma, the standard deviation, divided by the expected rate of return, and let's copy that for Mazziello as well, 0.26. Again, with the CV, like the sigma, smaller is safer, so the same conclusion is returned. Watson is riskier, Mazziello is safer with a very, very low CV as well as sigma, okay? So this is the riskier stock and this is the safer stock, all things equal. Okay, so finally part G, and I'll record a separate video for our other problems. Okay, here's my conclusion, friends. If sigma and CV disagree with each other, okay, always use the CV. Okay, the CV is going to trump the sigma. If the ERRs are different, okay, it's possible that the sigma and CV could disagree with each other. Okay, and that, friends, is problem number 4. I'm going to pause my recording right now. I'll open a fresh file for you momentarily, and we will conclude chapter 7. Okay? Hang on, be right back.